So a particle is hanged with a 1.25 meter long thread. Now the particle circulates in a vertical circular path when a 7.2 meter per second linear velocity is applied. So in this case we want to find out the particle's velocity at the highest point of its motion, and provided here is that g, that is the acceleration due to gravity, is 9.8 meter per second square. Now let us consider the figure on the right side. Here we can see that the particle is initially at rest. Here it is hanging from a 1.25 meter long thread. Now if a linear velocity v is equal to 7.2 meter per second is given, then it will circulate in this particular path. Okay, so what will happen, its velocity will monotonically decreases, and at this point it will be minimum, and again it will increase. And now our problem is to now we want to solve the velocity at this point, that is the b, point A to point B. It will move and then again come to point A, and but we want to calculate the velocity at point B. Now here you can see that the three forces works on this particle. Now in this case the forces are tension T, which is acting on the thread, and the force due to gravity mg here, and the centripetal force, that is mv square by r. This comes due to the circular motion. Now at point A, T on the thread will be, that is the tension on the thread will be the maximum, as the both mg and mv square by r, they are working in the same direction, that is away from the center of the circle, and tension is always inwards the center of the circle. So at the point A, the velocity will be maximum, which is given in the question. So now as the particle reaches the top, its height is increased by r plus r, so this will be 2r. Okay, so this indeed will increase its potential energy because it is increasing, its height is increasing. So we know that potential energy will also increase due to the increase in height, and this will be 2 times mg into r. So m is the mass of the particle. It is not given here, and we don't need it also for our calculation, that we will see later. Now according to the law of conservation of energy, the kinetic energy of the particle should decrease by the same amount so that the total energy remains constant. That is, the increase in potential energy twice mgr will be exactly equals to the decrease in the kinetic energy for moving this particle to point A to point B. The velocity at point A is equals to VA, and velocity at point B, that is at the top, is VB. So VB and VA. Now if you want to check its change in kinetic energy, that will be kinetic energy at bottom and kinetic energy at top, so equals to minus kinetic energy at top, so equals to 2 mgr. Now if we put the equation, that is half mv square minus half mv square is equals to 2 mgr. Now making this all calculation and everything, we can get this equation finally, that is the VB, that is the velocity at the top, will be root over VA square, that is the velocity square at the bottom, and minus 4 times g into radius of the circular motion or vertical circular motion. So putting all the values, we will get that the velocity at the top will be 7 meter per second. So the final answer will be 7 meter per second. Thank you for your kind attention.